Alright guys, let's get into some practice with free fall. Before we start the first one, number 6, I want to talk about how to solve these problems when you're throwing something up and then it comes back down again. When you're solving motion problems in the y direction, so like when you throw something up and then it falls back down, we need to think about the trajectory of the object in two different phases. First it goes up and then it falls down. Because the kinematics equations that we use, those three equations, are only good for one of those paths. They can talk about the path going up, or they can talk about the path going down, but they can't talk about both. So you have to separate, you have to distinguish between the two. Let's take an example here. You have some sort of initial velocity, and then it goes up, and for a brief split second, the velocity in the y direction is 0. Even if it's moving along in the x direction, like if you're throwing a football, even though it's still moving across the football field, its y component is 0 at the very, very top of its trajectory, and then it starts to fall back down again. And then when it gets to the bottom, the velocity is whatever it was before. So the velocity that you start with is identical to the velocity that it ends with when it reaches the same height. So let's talk about the up trip. Just on the way up, your velocity initial is some positive number that you start with. Your velocity final is 0. And your acceleration is gravity negative 9.8. On the trip down, your initial velocity is 0 because you're starting from that top point where your y velocity was 0. So you're starting at 0. Your velocity is some negative number that you're going to end with. Your final velocity is that negative whatever number at the bottom. And again, your acceleration is negative 9.8. How about the time? The time it takes to go up, as it turns out, is identical to the time it takes to come down. So your time on the way up is half of your total time, and the time on the way down is half of your total time. And you can add those two together to get the total time for your trip. So take a look at number 6. You throw a beanbag in the air and catch it 2.2 seconds later. Let's set this thing up. The 2.2 seconds for the trip can be divided into the time up and the time down. It takes 2.2 seconds to go up. Let me see if I can scroll back here. It takes 2.2 seconds for the whole trip, so that means 1.1 seconds up and 1.1 seconds back down for your total trip. So we need to divide this into 2 because we can only use our kinematics equations for one step at a time, either up or down. So you need your time up and you need your time down. How about the acceleration? That's going to be gravity. Your velocity initial is unknown. Your distance is also unknown. I'm going to solve for initial velocity first. That's backwards of the way it's written on the paper, but that's what I'm going to do. So let's write down some variables. Just for the up trip alone, we know that our velocity to begin with is going to be 0. We know that our we know that the velocity at the end is going to be 0 because we're going up, so we're going to finish at that high point where we're at 0. The initial velocity is unknown. We do know the acceleration, and we do know the time. So we can use this equation. We can rearrange it to solve for initial velocity, and then we can plug in our numbers. So now we have the initial velocity just for that up trip. For the time, or for the distance rather, we can use this equation, the VF squared formula. I'm going to rearrange it, solve for d, plug in my values, and I get 6.2 meters. So again, we only looked at half of the trip to solve for the information that we needed. I chose to do the up trip. If you had done the down trip, that also would have worked, at least to find the distance. But you can certainly do it that way. Okay, number 7. For the up trip, our velocity initial is given. Our velocity final, if it's the up trip, is going to be 0, because at the end of that going up, you arrive at 0 for a brief second before you fall back down again. The acceleration is gravity. The distance is unknown. we can use our VF squared formula. Let's rearrange it to solve for d. And then we can plug in our numbers, and then we get the distance for the up trip, which is the height that it goes, right? So the question is asking, how high does it go? What they're really asking is, what is your value of d for your trip up? Or what is your value of d for your trip down? That's the same thing as the height. How about time for part 2? How long does it take? So you need to pick an equation that has t in it, as well as some of our other variables that we've already written down. The easiest one is this one right here. We can rearrange to solve for the variable t. Velocity final is going to be 0. Initial is going to be the given. A is going to be acceleration. So there we go, 2.3 seconds. But be very careful. This is only half of the time, because we're only doing one trip at a time, so this is only the up trip. So if you want to know the total time that the ball remains in the air, up and down, you got to double it. Remember that the time it takes for the object to rise is equal to the time it takes the object to fall. So when you solve for time in these problems, you have to double it to get the total time of your trip. Let's take a look at number 8. Looks like the whole thing kind of just went at once. Oops. What are we doing? What are we doing? Here we go. Okay. For the up trip, take a look at what we're given. Velocity initial is unknown. Distance is given. The acceleration is going to be gravity. The final velocity is 0 because we're talking about the up trip. When you arrive at the top of your trajectory, your velocity is 0 just for a split second. So for the up trip, we can say that the VF is 0. We are solving for velocity initial, so take a look at your variables, find a suitable equation. The VF squared one is going to work for us in this case. Let's rearrange it to solve for velocity initial. So I'm rearranging this before I even plug in my numbers. Then I'm going to plug in my numbers here, and I can find the velocity initial. How about the time? Take a look at your variables, pick an equation that has t in it. This one's going to be the easiest. Rearrange it for the variable t. Let's plug in our numbers, and then we have a time. But that's not good enough. This is only half of the total time, because we only solved it for one leg of the trip, the up trip. So if you want to get the total time, you have to multiply that by 2. Alright, I hope that this was helpful.